So finishing up our trig chapter or trig unit is really about putting it all together. So the summary of our tools so far that we've developed is that we talked about how the sum of angles in any triangle add up to 90 degrees, and we're dealing with right angle triangles. So we were often doing the missing angle was 90 minus the known angle, because that gave us the missing angle in the easiest way possible. The next tool that we had was the Pythagorean theorem. And the Pythagorean theorem, people usually do remember it. That was the sum of the squares of the two sides of the triangle equals the square of the hypotenuse. And that was all about sides of angles. So we did all about, sides of triangles. So we did all about angles and we did all about sides. And then we had the trig ratios, the SOHCAHTOA, the equations that are written out here that really put angles and sides together. So we could practice solving for a missing side or practice solving for a missing angle if we had two sides. Bottom line on these, we can use all of these tools. If we have two pieces of information about a right angle triangle, we can get all the other pieces of information. So in this one, I'm going to start with this example that's at the bottom of the page here. And I'm going to start by labeling the triangle. We had that convention where the sides that were opposite to the uppercase letters or the angles were the lowercase, right? And in this, we have a number of things that we need to solve for. So we need to solve for side B, we need to solve for side C, and we need to solve for angle A. The other pieces of information we already have. And so in these, I'm going to go about demonstrating my work, showing all three of these skills. I'm going to start with the easiest. I'm going to solve for angle A. And angle A, the easiest way to get there would be to take 90 minus 50 equaling 40. Angle A is 40 degrees. And so I like to sometimes label it on the triangle here. So this is 40 degrees. Right, let's move on to another piece of information that we can do. So the next thing I'm going to do is choose a side to work on. I'm going to solve for side B. In solving for side B, I'm going to take a look at the angle that I was given, and I'm going to label the sides that I know. So this side is adjacent, and if I'm looking to solve for side B, that is opposite. That means that I'm going to be dealing with the trig ratio of tangent. So I'm going to write tan 50, I skipped writing out the equation, it's right there if you need it, would be B over 9. And solving for B, I would use that B equals tan 50 times 9. So just calculator work here. Side B ends up being 10.7. No units given on this, so you don't have to put units in your answer. I'm going to add that here. So what did we just solve? 10.7. The last thing that we need to do is solve for the last side. Now you can use trig again to solve for side C. Just to make sure that I'm covering all my bases here and reviewing all of the skills, I'm now going to solve for side C with Pythagorean. And so we know that 10.7 squared, I put brackets around it this time, don't know why, they don't really do anything, equals c squared. So c would equal the square root of this 10.7 squared plus 9 squared. Showing it like that gives you the skills to put that in your calculator. My programming updated and my notes are a bit scratchy now, sorry. Haven't figured out how to reprogram my tablet. Regardless, we get a c end up being 14.0. In all of these, I will give you rules for rounding. They're somewhat arbitrary. I tend to go to 1/10 of a degree for sides, so 1 decimal place for sides, and the nearest degree for angles. But I'll try and make sure I specify that in the questions for you. So we're going to practice this. There's a lot of ways you can get to the right answers. It really is a bit of a choose your own adventure. You could use the trig ratios for everything. So this page, I'm going to show you my work. The next page, I'm just going to put the answers on and give you the challenge to try and get to the full solution. So I'm going to start with solving for angle A. A is going to be equal to 90 minus the angle that I know. And so angle A would equal 28 degrees. If you like to put that on your diagram here, just to make sure that you're keeping track of what you've solved for, you can absolutely do that. Oops, I forgot to label my triangle too. That makes it easier to talk about. So this would be side C, this would be side B, and A is over here. So we're looking for side A. We're looking for side C now. So you can choose whichever one you want to do. I'm going to solve for side A. And in solving for side A, I'm going to use my reference angle that was given to me, and I'm going to label these up. This is adjacent, and this is opposite. I'm not working with side C yet, so that means that its tangent of 62 would equal 22.6 over A. This one I have to remember that I swap and divide. A would equal 22.6 divided by tan 62, and A would equal 12. So if you like, you can put it on the diagram if that helps you make sure that you're getting every piece of information solved for. The last piece of information to solve for here would be the hypotenuse, would be C. So solving for side C, I would use Pythagorean theorem. So I have this newly figured out 12 squared plus the 22.6 squared equaling C squared, right? That's fitting it into that Pythagorean theorem. I could say that C equals the square root of those two squares added together. My calculator would help me out with this, that C, rounded to a tenth of a place here, is 25.6. And that's the last piece of information that I need. Remember, we do have that freebie. We have that 90 degree in the corner because these are all about right angle triangles. So let's do another one. Let's take a look at the next example here. So in this one, I'm going to start better. I'm going to start by labeling it. So we'd have side C, and that's a bit of a question mark for us. We know that this is our side A. That's a given. This would be opposite to that given. We would call that side A, and this would be side B. So I start with the easiest thing. I start with the missing angle. So I know that angle B is going to be equal to 90 minus the angle that I know. Angle B is going to equal 39 degrees. So that's the first piece of information. And why not go with the easiest way to figure some of it out? So moving on to the next thing I want to figure out, and you can choose whatever it is, right? Remember, we're working on either side B or side C. I'm going to pick on side B. I'm trying to do these kind of in a similar way to give you a little bit of continuity. So solving for side B, I'm going to use trig. And if I have side B, that is adjacent to my angle that I was given. And so that tells me which trig ratio to use. It would be 9 over B. And solving for B, remember to swap and divide. I'm a little out of space here, so I'm just going to write the answer of 7.3 inches. If you want, you can label that on your triangle. So we've got that fill in the blank here of 7.3 inches. Doing the last one, and again, trying to stay kind of continuous here, I'm going to use Pythagorean theorem, but you could use another trig ratio. In solving for C, I would have that 7.3 squared plus 9 squared would equal C squared. I could do that on my calculator. If you like to write out the instructions for yourself, then go for it. I'm going to start dropping that because I tend to just do it in my calculator. C ends up being 11.6 inches. So now we have all of our information. We've solved the whole triangle given just the two pieces of information. Two more down at the bottom, and I'm going to show all of my work on these. You might be deviating from my steps. If you're doing it in a different way and still getting to the right answers, that's absolutely fine. In this one, I'll label everything that I can. I'm looking for some key pieces of information. I like to highlight those in red on my notes here. So those are the 3 pieces of information that I'm looking for. I'm going to start with the easiest thing. Because I know this 42, I know that angle A is going to equal 90 minus 42. Angle A would equal 48 degrees. After I've got that, then again, I can choose whichever one that I want to solve for. I like leaving my hypotenuse, but you don't have to. You can go after the hypotenuse next. In this one, I'm going to now take a look and solve for A. So I'm going to solve for side A. That's what I'm doing next in my notes. So side A would be adjacent to this reference angle that I was given. And so because I have my opposite and I care about my adjacent, that's the tangent ratio. So subbing into that tangent ratio would be opposite over adjacent, and solving for that A with my calculator, remembering to swap and divide and round if necessary, you get that side A is 5. No units given on this one, so just the numbers fine. And the last one, solving for side, whoops, I just did that backwards. I wrote that in the wrong place. Easy to get lost. Where was I? You're probably ahead of me now. 5.0. So solving for C, I'm going to use Pythagorean theorem. C is going to equal the sum of the squares of those two sides. So we would have 4.5 squared plus 5.0 squared would equal C squared, because C is my hypotenuse. C would actually equal the square root of those two things, and I could put that into my calculator. So C would equal 6.7 in this triangle. Okay, last one on the page. You start by kind of labeling it a little bit. I've got 3 pieces of information that I'm looking for that I don't have already here. And I can really choose however I want to get there. I'm going to do the easiest thing first in solving for angle A, because A would equal 90 minus 53. Angle A would equal 37 degrees. After I do that, I can do whatever I want. I'm going to maybe pick to solve for side B next. When I take a look at side B, I have to label up. I'm going to use trig for this. And so B would be opposite to that 53-degree angle that I was given. And my known would be hypotenuse. So that would mean it's the sine ratio, and it's sine of 53 equaling opposite, which is B, my unknown, over my hypotenuse, which is 5. Remembering when that unknown is up top, that was where it was a little different. So keep things straight here. And my calculator would help me out that B equals 4.0 meters. The last one, you can either use trig or you can use Pythagorean theorem. It really doesn't matter. Again, I'm going to do it with Pythagorean just to kind of give you equal opportunity to all of the skills. If you get to A equaling 3.0 meters, you've got the right answer. So the way I got to that was solving for side A. Using Pythagorean theorem, I'd have A squared plus 4.0 squared equals 5 squared. So A would equal the square root of 5.0 squared minus 4.0 squared. A would equal, on my calculator, 3. Don't even have to round that one. All right, so the next page, I'm just going to put the answers up. And I really think that there's a number of ways that you can get to these answers. So this will mostly just make sure that you're making it make sense for yourself. But it should be, more of the same. Nothing different on here. The last bit in the notes is an application, and this question is a little bit goofy, and so I've kept it in the notes because it does need a little bit of help. In most of the applications, you're given a diagram, which can make this really, really a lot better. And so basically, this question is about three different things. So there are some rocks with some sea lions on it. So this is my sea lion here. There is a boat in the story. And there are also some whales. And so I'll draw you a little whale here in the waves with its tail up, and it'll spout water if you're with me on this. Okay, so we're going to fill this out. He can be smiley too. So we're going to fill this out with some of the information in the question. So the question says that there is a whale watching boat that initially stopped near some rocks looking at some sea lions. Then it's going to go 95 degrees due west, or sorry, 95 meters due west to head towards a possible whale sighting. The captain's going to point out a pod of whales, which the radar shows are 140 meters north of the boat. It says then, how far are the whales from the sea lions, and what is the angle at the rock between the boat's path and the whale's direct lines to the sea lions? So we want the information about sea lions to whales, if we will. So what we're looking for is the length of this line. We can call that x, and we're looking for this angle measurement. We can call it theta. And so those two pieces of information are what we're going to use here. If I solved for the angle first, I would care about my triangle relative to that. And we haven't done any examples that started with just two sides. So I think it's worth seeing this in the example here. So this would be adjacent, and this would be opposite. So if I want to solve for my theta, so solving for theta, I would choose the appropriate ratio. So because I have opposite and adjacent, that's going to be the tangent ratio. So I'm not writing out my equation anymore. Tangent is opposite over adjacent. And by doing this, I can then sub in and solve for theta with my calculator. So that theta is 56 degrees. And so that angle between the purple and the red line here is 56 degrees. That's the second, actually, question that it was asking. The other question that it's asking is solving for x. And with this one, you can go back to that angle, but if you've made a mistake with that angle, then it's going to throw off your value for x. In solving for x, I'm going to use Pythagorean theorem. So what we got, 140 squared plus 95 squared would equal x squared. X is the hypotenuse here, and so that's subbing into Pythagorean theorem. X would equal, in your calculator, the square root of those two things added together. And x would equal, I think we have to round on this one, but that's okay, 169 meters. So there's a few more applications in your assignment, but that pretty much does us. So you have an assignment page for your trig stuff, but there is no practice test. And then it's just the final review and the final.